problem we have today is an optimization problem, and it is find a point on f of x equals 3x plus 2 closest to 4, 0. So what I'm going to do is I'm going to label 2 points. One is point A, and point A is the point we have here, 4, 0. And point B is an arbitrary point, x, y, that lies on the function f of x equals 3x plus 2, that is closest to 4, 0. So now I'm going to start optimization, and what we want to do first is to write our known and unknown equations. So our known equations, in this case, a known equation would be the y equals 3x plus 2. And our unknown equation would be the distance formula, since we're trying to find the point closest to the point 4, 0. So we try to find the distance that is the smallest. So the distance formula says d squared equals the x coordinate of the second point minus the x coordinate of the first point squared. So x minus 4 squared. And again, plus the same thing with the y. So y minus 0 is just y squared. And now what we want to do is we want to substitute some variable in here into here. And remember, we want the whole right side of the equation to be one variable. And notice how we have y equals 3x plus 2. And we have a y squared here. So why not substitute this 3x plus 2 into y, the bottom function? So we get d squared. If we do that, we get d squared equals x minus 4 squared plus 3x plus 2 squared. Now notice that the whole right side is has just one variable, and that's x. So now we can actually take the derivative of this. And I'm just gonna get rid of this squared, because if we have a max or a min, if you take the square root, it's still going to be the max or a min. The point is still going to be the max or a min. So the square doesn't matter. So in this case, all we have to do is take the derivative of this. So we need to find, right over here, dd dx, or the derivative of d in respect to x. So I'm going to treat these, I'm going to take the derivative of these two separately. So power rule will kick out a 2. So 2 times x minus 4, remember we have to keep the inner function when we do chain rule, times the derivative of x minus 4, which is 1, so that just stays the same, plus, I'm going to kick out a 2, so 2 times 3x plus 2, remember to subtract 1 from the exponent, and we have the chain rule, kicks out a 3, since you have to multiply by the derivative of the inside, so times 3, this equals, this would be 2x minus 8, right, if we bring the 2 inside, plus 6 times 3x plus 2. This equals 2x minus 8 plus 18x plus 12. Now if we add like terms, we get 20x plus 4. So the derivative of that would give us 20x plus 4. And remember, we need to find the max or a min. We need to find the minimum value for x. So we need to set this equal to 0. So we need to set the derivative equal to 0. So we need to set 20x plus 4 equal to 0, and if we do that, notice how we get x equals negative 1/5. So just because we just got a value of x equals negative 1/5 doesn't mean that that's actually a min, and we actually have to test that. So let's use the number line test to test that. Let's have negative 1/5 over here. Remember, we have to test the point left and right of it into this equation, and we have to look at the signs. So let's say we pick the number left of negative 1/5. Let's say we pick negative 1. If we plug it into the derivative equation, notice we get 20 times negative 1 plus 4, which is obviously a negative number, so we can draw a negative sign and a down sloping slope. And if we pick a number right of negative 1/5, let's say we pick 0 and we plug it into the derivative function, notice that we get a positive number, so we can draw a positive upsloping line. Notice that it makes a value, right? It makes a v. So in this case, the negative 1/5 is actually a minimum. So we proved that negative 1/5 is the x coordinate of the point xy, and that it is actually the minimum. So now all we have to do is we have to find the y coordinate of that point. We have the x coordinate, that's negative 1/5. So to find the y coordinate, all we have to do is plug negative 1/5 for x into here, and if you do that, we get y equals negative 1/5 times 3 is negative 3/5. Plus, remember 2 is 10 over 5, plus 10 over 5, and this equals 7 over 5. So we can write our point B as, so point B, or the point closest to 4, 0, on the function f of x equals 3x plus 2, equals 1/5, negative 1/5, comma 7/5. So this is the point closest to the point 4, 0. Thank you guys for watching, and see you next time.
Greed is stress, and emptiness is all around.